Hello everyone, my name is Rahul and welcome to my channel DevOps Forge. So in our previous videos, we have learned the core concepts of Terraform, the life cycle in which we have learned about the init, plan, apply and destroy and the important files which Terraform creates. So in our today's video, what we are going to learn is the third topic, which is Terraform configuration language HCL deep dive. So these are the core components of HCL and which includes resource blocks, Terraform data types, input variables, local values, and outputs. So it can be a lengthy video. So stay tuned and let's move ahead. Now, Terraform is written in Go language. So let's start from here that Terraform is written in Golang and its config files are written in HCL. So far, you know what HCL is, and then so the HCL is designed to be human readable and it is declarative. You know it very well now. And then it is structured and also parsable by machine. Right? So if I take a basic example, so in our previous video, you know we have created one EC2, right? And we have defined a resource block over there. So the general syntax, the general syntax of Terraform is the block type and label 1 and then label 2 and then we have argument and value, right? So the first thing is this block type can be called as resource or outputs or data or variables. So this is a resource type which you can say for block type. And then in the label 1 we have what type of resource you want to create. For our example, in our previous video we took AWS instance, right? So this is resource type. And then we have resource name. So this is the resource name which is going to be recognized throughout your code. So for example, if you have named this as web, then in that case you will call this resource, this particular block in your configuration language, in your configuration file, sorry, through web only. And then we have argument and value where you can have multiple argument, but in our previous case we had instance type as an arg and t3 dot micro was the value, right? So the core components of Terraform configuration are resources, data types, variables, locals, and outputs. So all of these work together to define your infra. Now, the next thing we need to understand to learn HCL language is resource address. Now let's see. The format of calling your resource is resource type dot name. Like I said, when you have created any instance or any resource, so these resources should be, or you may want to call it or use it or reuse it in your configuration file. Or let's say you have created a security group, right? Let's say you have created a security group and this security group needs to be used by our EC2 instance. So in that case, the dependency is there, and this security group should be called by EC2 instance so that the firewall rules can be added in this EC2 instance, right? So the resource address, which means how your resources are going to be addressed in your configuration files, and the example could be AWS instance, which we created in our last video, and dot web server, right? Now the next topic is arg versus attribute. Okay, now values generated by the provider after creation is called attribute, and arguments is values you define in the configuration. So the argument could be instance, type, and t3.micro, right? So this is argument, and attribute could be your public IP, your ARN, or your ID. So understand this in this way. The attribute is like you have created an EC2, right? So once your EC2 is created, it will have a public IP, it will have a ARN, and it will have a ID. So if you want to address or use these public IP or ARN or ID or reference it in other resource blocks or other resources, then in that case, the attribute is the one which is taking care of, right? Now, the Terraform data types, we will understand it, and Terraform supports several data types, and we have some examples over here. So this is the string, which I think we should not discuss it, because string, number, boolean, these are the data types which you will see in all the programming languages, and it is a very simple one. So let's just quickly understand this, that the type is equals to string. When you provide this argument, then it will behave as a string, right? And the usage could be this can be used as a tag inside any of your resources, right? Now you have the second thing, which is number. When you want to define the instance count, let's say you want to provision EC2, and this has to be two instances, like you want to provision two servers, right? So in that case, number is helpful, and boolean, of course, either it can be true or false. Now let's understand set, because this is a bit different, like how it behaves in other programming languages and how it behaves in HCL. Now understand this thing. Terraform does not support directly accessing elements of a set by index, because sets are unordered collections. So to access elements in a set by index, you should first convert the set to a list. So this is our set, right? Now what I have done over here is I have converted it into a list. So this is a list, right? So this particular set is converted into this list because Terraform does not support directly accessing these sets, right? So you will use the toList function. This is the toList function, which is used to convert the set into a list, right? And the example is this one. Now you can then reference an element in the list using the using in this format, right? So as you do it in other programming languages, like for example in Python, you can access the list now through the indexing, right? So this is very important. You need to understand, whenever you are defining a set inside a Terraform configuration file, then you must take care of one thing, that using the toList function, you need to convert the set into a list and then access those elements or those values through the indexing part. Now let's understand list. So this is also a very easy one, like you have used before. So you can use a list of values. Over here, if you take this example, we have variable as an availability zones, and the type is list of string. Okay, so these are the two availability zones I am taking over here, and then how I am accessing it through indexing. Like This means it will pull US East 1A, right? Similar to what we have seen in Python. Now we have map. A map stores key value pairs, right? So the example could be this one where you see over here is tags. So I am taking the map of strings and I have added key value pairs of environment equals to dev and the project is Terraform demo. Now the usage could be you can use these tags inside your resources and you can segregate your tags, like if it is for dev environment then it will place those tags into those particular resources. If it is production or it is staging then it will configure those accordingly, right? Now we understand objects. So objects allow structured values, right? And the example is this one where I have defined the type as object and instance type is string and volume size is number. So EC2 instance type would be over here is string. So I can say t3.micro and the volume size could be a number. For example, I want 20 GB of storage mounted to my EC2 instance. Then this could be helpful, right? Now we will understand tuple. So tuples are a type of complex data structure that allows you to group multiple values into a single value. They are similar to lists but have a fixed number of elements, each with its own type. So the example could be this one, the server config, where the type is itself object and we have instance type string and volume size number, right? I think I have copied the wrong one from here. Let's see. I guess this is the one for tuple. So these are the lecture notes in the GitHub I have placed, and I'm taking these examples only to explain you guys. So by by mistake I have copied the object one. So sorry for that. I mean, let's change it and paste it over here. So this is the one. Like like you have defined type object or string or list. Similarly, you will define the type equals to tuple and then we have string, number or boolean value. Now understand this very clearly and take a note of this, that elements of list, tuple and map values can be accessed using the square bracket index notation. Like I said, you seen over here, this is called square bracket index notation, right? So sorry. So this is called square bracket index notation. Let's add this like this, square bracket index. So this is an SBI notation. Okay. So like this example, you can access the elements of list, tuple and map values. Okay. And the expression within the brackets must be a whole number for list and tuple values or a string for map and object values, right? So object allows dot notation also, like if you want to call your elements of any object then you can call it by using the dot notation as well. So uh, this for example, let's say I want local I will explain this later. I want local to call server configs this element instance type. So I can use dot instance type, right? So there are two ways to access the objects elements. First is dot notation and the second is square bracket index notation. So in both the ways you can access the object. Now you understood this one, okay? So you must be thinking that in all the other data types we are using a specific way to access the elements of that particular data type, but why it's different for object, right? Why bracket notation is sometimes preferred, or why Terraform has given a special uh, power to objects, right? So If the keys are dynamic or user defined, so dot notation may not work. So let's say, for example, in your locals block, what you did is you added a user tag, okay, which is your project name, and it is Terraform practicals, like this. Okay. So dot notation, this dot notation will fail over here because you can see this hyphen, right? So if you want to access the objects through the dot notation, then in this case um, the value over here will not be fetched because you are using a hyphen over here. And in some of the projects, these are the standards or the standardization they use for their convention, right? So the project name contains a hyphen. That is why in this case, what it will do is we can use the SBI, which is square bracket index notation. So in this case, I can access the project name in this way, right? You have understood this part. So let's move ahead with the next thing, which is input variables. So variables make infrastructure dynamic and reusable. So many a times we have seen over here that I am using a concept called variable. So this variable is helpful to make your infrastructure or your config files dynamic and reusable, so that you can access these variables or you can define these variables in a different file and then access this, so that you can repeat the number of accessibility of a particular variable inside your Terraform block, similar to what you have seen in other programming languages where we define a variable and then we use it in multiple areas and we define it once, right? Now we have variable validation. So Terraform variable validation ensures that input values meet specific constants before applying configurations. So preventing misconfigurations and improving reliability, you can enforce. Let's just add the topic name first, variable validation. So like I said, the variable validation ensures that input values meet specific constants before applying the configurations and preventing misconfigurations and improving the reliability. So you can enforce rules using the validation block inside a variable definition. So if I take a basic example, there are various ways of validating. So I'll be covering this part into my next series, or I'll make a dedicated video upon this. So what are the best practices using this variable validation and what are multiple types of variable validation, right? So for example, I am defining a environment, right? And I'm saying the type of this environment is string. I'll add some description that this is my deployment environment. Okay, just a minute. And then I will add a validation block. So this is what I was talking about, and this is an important part where I will add a validation block and I will write a condition that the deployment environment should contain dev or staging, right? And I will take the environment value through my variable file. Okay, so like I was saying, this variable, for example, I have defined environment over here as a variable somewhere, and I've said add a value here which is what, dev. So I want my deployment to be done on dev environment. So in this case, what this validation will do, it will basically checks this condition that whether your particular variable environment, this variable which you have defined before, contains dev or staging, right? And then if the condition is fulfilled, then it will do the deployment. Else, let's say if you have added production over here, then what it will do, it will basically fail over here and say, and give you an error, right? That the value of the environment is not dev and staging. So you must change it to dev or staging, right? And one more thing over here is, let me just add this. You can also print the message that environment is not equals to dev or staging, right? You can think of this like the try catch exception which we use in Java. So in similar way, this is the one where we are catching the exception, we can say, which is the error message. And you just take the example of Java just for your reference to understand this, but this is how you do the variable validation. Now let's move ahead with another topic, which is variable sources, right? So variables can come from default values. The default values, if you define it inside your configuration file, it can be come from your tf-vars file. I'll explain this. What is this? And CLI variables as well. CLI means, for example, you have added Terraform plan or Terraform apply command, and in that case, in your command line interface, you will be prompted to add the input, right? And it can also be environment variables. So these are the type of variable variable sources, right, which we can define in Terraform. Okay. The next important thing is locals, right? So far what we have understood, multiple data types, right? And why set is converted into list, and then we access this using SBI notation, square bracket index notation, and object is a special case where it has two ways of accessing the elements. First is the dot notation, this one, and the second way is square bracket index notation, right? Now then what we understood variables, then we understood what is variable validation, and then we understood variable sources. Now locals. So locals are basically temporary values used within Terraform configuration. So they basically simplify the complex expressions, and you can use it in your main file or any other files, but majorly it is used in main file. And this local is defined in such a way that environment equals to dev, and you have instance name. So from this example, it will get clear that why we use local. So let's say I'm using local dot environment to reuse this as a instance name, right? So these are short-term, short-lived or temporary variables which are used inside your Terraform configuration files. And the benefits is you can avoid repetition through this, because once defined, you can use it in any of the resource blocks. You can compute the derived values. In this example, local dot environment, I'm using the dot notation to access this local dot environment. So throughout the Terraform, you can access the variables through dot notation, but there are some cases where the square bracket index notation is used, and which I have told before, right? You can compute the derived values. Okay, and then you can improve the readability of code. Can improve the readability of code, right? Now let's understand one more topic, which is outputs. Okay, so outputs is basically whenever you have configured your code, you have written all your configuration and all your resources blocks and everything, then what will happen? You want to output the, for example, the public IP of your EC2 instance, or the ARN, or the ID, or any other configuration. So in this case, outputs exposes the information after your infra, after, this is important, after your infra is created. Now, I will take this example in the code part where we'll take an example code and we'll understand what is outputs. But for now, just understand this. If you want to access any of the configuration from your resources after the creation, then in this case, you can use outputs. Okay, so outputs are useful for displaying your infrastructure info and passing values to modules. So there is a concept which is called modules, which we will understand later. But just for now, understand this. You have some of the configuration files and you have added the command terraform apply, and it produces some outputs, right? So these outputs can be fed into your modules as an input as well. So for example, module 1 produces some output, okay, and module 2 is there, and this module needs to fetch some of the output from here, from module 1, to get applied or to provision the resources. So this output will be passed to the module 2 from module 1, and it can be reused. And also you can integrate with other tools as well, but let's not understand that. So there is one more important topic, which is Terraform file structure. So from now we are not going to add all the configurations into a single file which is called main.tf, because that is what we do not follow in the enterprise world, or you can say that is not a standard process. So there is a process through which you can structure your file system in Terraform. So we will deep dive in advance how IT companies structure their Terraform files in the later video, or I'll make a separate video out of it. But for now, just understand the basic so that you'll be able to understand that how today we are going to use the example code and add the configurations. So we have, first of all, providers.tf. The name itself suggests it will have the provider configuration, and Terraform should use it and authenticate you through your credentials, right? Second is main.tf. So far you understand that what is main.tf clearly. It will have your main configuration, actual infrastructure logic. Okay. Third is you have variables.tf. So we have discussed so far what are variables, right? So all the variables are added into this particular variables.tf file so that we can reuse this in our later configuration files. Okay, so it defines the input variables and it allows us to make the configuration flexible. So instead of hard coding the values, variables allow customization through your external outputs, right? Next is we have tf wars file. So what is tf wars? Basically, the tf wars files are used to assign values to variables. So you have variables.tf file over here. So you have some particular variables, for example, variables configuration inside this, and you want to pass the values to these variables configuration through this tf so uh, where it is used, I mean, how is it helpful to the variables.tf? Because let's say, for example, you have multiple environments: dev, test, stage, production. And in this case, you have one single file which can handle these values, and these values could be passed into the variables configuration. So in this way, what flexibility it will provide? You will not need to change your variables.tf again and again, again and again. No configuration change. So think of it in this way. So let's say I have this file structure and my variables.tf have one variable which is called environment, right? So if you want to deploy your application into dev environment, then you will add the value as dev. Before that, you will say that type is string, right? And if the next time you want to deploy your application into test, so will you go and change this again and again, like add the value the next time you do it for test, the next time for stage, the next time for prod? Will you do that, or is it feasible? No, right? So in that case, what will happen? You have a single file, make changes to this one, you make this standard, which can be reused, in your configuration files, right? And the last one is outputs.tf. So outputs allow Terraform to display useful information, like I said, after resources are created. So let's just quickly go to the top and revise a little bit, and then we'll directly jump into the example code. So understand this. First thing, Terraform is written in Golang, right? And the configuration files of Terraform is written in HCL. So HCL have human readable. It is declarative, structured, and parsable by machine, right? We understood what is the general syntax, how Terraform behaves with this general syntax. So we have the standard like block type. It can be outputs, resource, data, and variables. We have seen this, and we have arguments and values over here. The label one is resource type. Right? Which type of resource you want to define in your configuration file. And the label 2 is resource name, like web server or example server or anything, which will be later addressed or referenced into your further resources. The example I've given you is security group, which is like EC2 instance, which is dependent on security group, and these values will be used through EC2 instance. Then in that case, the dot notation, using the dot notation, you could be able to call the security group inside your EC2 instance. Then we understood what is resource address, right? And then we understood arg versus attribute. Attributes are after the creation of your resource, whatever configuration you want to fetch or you want to reuse it in your configuration file, those are attributes. And arg is, we know that clearly, right? It is instance type, and t3.micro is one of the example over here. We understood multiple data types, right? And then we understood what is variable validation, and variable sources. These many are the variable sources, and one of them we used is Terraform tf-vars, right? And we have explained that what is tf-vars file, and you can also add any name before this dot notation, but this is a standard process where many of the developers in the industry use Terraform.tf-vars, right? Default values is directly inside your variables.tf file. You can define the default values. The CLI variables are when you do the Terraform apply or plan. So in the command line interface, you will be prompted to add some input, and the environment variables is what you can set inside your configuration. We have locals, which are temporary block and temporary values. So these are short-lived values, and this can be reused and is beneficial when it comes to avoid the repetition, the derived, and we can use these derived values and improve the readability of code, right? We have outputs. I've explained it very well. Then we have Terraform file structure, which is the most important. And in our later videos, we'll cover it in advance, right? So these many are the concepts which are basically very, very useful for you to code in HCL. So these concepts will help you to write your code, and just like in Python or any other programming language, you first understand how to write the code, what are the data types, what are the sources, etc. Similarly, today we understood how HCL is written, how we write the HashiCorp configuration language into our Terraform configuration files, right? And like we call, like in Python or any other programming language like Java, we call some of the variables. Similarly, we call it in HCL as well. Now just quickly jump onto the code and understand this through an example. Okay. So I will go over here, lecture 3, and I have added these notes. So I will add the GitHub repository URL in the description. You can understand all this which I have explained, right? So I'm inside the folder lecture 3. So quickly, what I will do first, I will add the providers.tf file, right? First step is what you do, you add the provider, which provider you want to use, which cloud you want to use. And I told you, I don't like, you don't need to learn it how to code. Just go to the web and say Terraform required providers. First one is the Terraform registry. This is very helpful registry. Go through it, read each and every code, and you will be able to learn it very quickly, and it is very easy, right? So before that, I will add that this is the providers.tf file. So the autocomplete is what interrupting me, right? We understood this before, what it is, so don't need to repeat that. I will add the required version, which can be greater than or equal to 1.5.0. If you want to understand what is providers, then you must watch the previous videos. So now this is done, right? We don't need to add something else over here, but we will make a change for sure, because today we are understanding how to write the code, and the best way to write your code is dry, right? Don't repeat yourself. So the dry is the concept where you don't repeat yourself. So I will do not hard code any value, and I will standardize it, but we'll do that later. For now, let's create the most important file, which is variables.tf. It will have all our variables, and you will understand that how we write the variables. So I will add one by one example how using the data types. So these are the data types which we understood. So I will add one by one comments of for these data types, so that you can understand it one by one how it is used into the configuration file and why it is useful. Okay, so let's add a comment that this is my variables.tf file. Oh no, the auto completion is okay, so let's forget that. So I will give an example of string, where first thing I told you, we will not hard code anything. So in this case, AWS region is what you want to define, right? So AWS region is type. Like I said, you need to define the type of the data type you are using. So in our case, this is what? This is our basically string data type, right? And description I could give over here is uh, define your AWS region. Okay, so now we understood. Next thing is we understood the number data type. So quickly I will add the instance count. Okay, so uh, basically I want two instances of my to be running on my AWS account. Okay, so type is, so far you have now understood. See, the auto completion itself is telling you or suggesting you that what you can use over here, and description I can add is the number of instances you want to define, right? Next thing, let's move ahead and understand what is Boolean. Okay, so let's say for my EC2 instance, I want to enable monitoring, right? So in this case, I will add the data type to be bool. Let's just remove the space here, and description is enable or disable monitoring. Okay, so let's move on to the next topic quickly because this will take some time. Okay, what I did, yeah. So list, we have list variable. So what I want is in our example, like we took the example of availability zone. Same example I will take over here, availability zones. So this is a very basic syntax if you see so far. That is why I'm able to write this code without even going through the documentation. The type is, if you remember what I have explained, you need to add the type and we will add list of string, right? And all these values, if you see all these variables which I have defined, I am not adding it any value to it. So if I would have added any values over here, then it could be an example of input variables, right? And today we want to take examples of tf wars file, right? So next is set. Let's quickly move ahead and add that. So for set, let's say mm, 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 let's say for my EC2 instance, I want to allow some ports to access, right? Later I will add that it could be the 22 for SSH to open the SSH tunnel so that we can access our EC2 instance, right? Now you got all this configuration. The next we read was set. Till set I remember it. We've used list. Now comes map, object, and tuple, right? So quickly just use the example of map, where basic example is you can use tags, right? And it what map does, it accepts values in the format of key value pair. So first step is add the type of the variable, and then let's keep it aside. We do not need to add description for each and every variable. uh, you will be able to understand it, right? And for object, okay, what I'm doing wrong, variable, okay. So let's say for objects, the example which we took is server config, right? So what I will do, I will copy this and add it to my code. Don't need to write each and everything. Okay, something happened, yes. Type is object. I think they want us to write. So let's do one thing. I will remove the trailing spaces. Let's add this in this way. Volume size. Now we are good to go. Last thing is tuple. right? The variable. You can take any example, like let's take example tuple only. Let's say the tuple. Wait, let's frame it in this way. Tuple example, and it accepts what kind of what kind of value? Sorry, tuple. Okay, and the multiple values could be string, your number, your pool. Okay, and the last block is for variable validation. We can also add this variable validation. So you add environment, the same example I'm taking, which I took in the whiteboard, which I have explained. Type is string and validation. So what is the validation I want to put, right? Condition, sorry, condition is it should contain it should contains um, dev or staging. Okay. I think I missed something. It is saying wrong. Let's see what is the error. Required attribute is this. Okay. Okay, there is one more mistake over here. Right, staging. And we take one more input. So this we will take from the TFORS file. Okay. I think. Okay, this one is the part where I'm missing something. Okay, now let's add the error message that environment must be dev or staging. That's it. So you understood, right? These are the data types which we understood, and we are using it as an example over here. Next thing is you want to pass the values to this particular variables.tf file. So in that case, what I've told you, you will need terraform.tf wars file. Now I will add the AWS region and see it is giving me auto completion. I will say US East 1. Now instance count. Let's keep it 2 and enable monitoring, and it was boolean, right, if you remember. Next thing is availability zones, and first we had US East 1A. The next we had was US East 1P. Okay, these are the availability zones where I want to deploy my resources. Now what will be the allowed ports? Let's see. AWS region, instance count, monitoring, availability zones is done, allowed ports. Okay, so this is what I've said, that for my EC2 instances, which ports should be allowed. Okay, so I will do 22, and let's say one more is I think for MySQL we use 3306 MySQL port. Yeah, 3306. Okay, so let's say I want my instance want to connect to the database as well. So we'll allow 3306, right? Next, common tags. Okay, let's copy this, add it over here, and let's say common tags will be add the name of my project as Terraform data types, and let's say owner is Rahul. Okay, next thing is, let's see, Common tag server config. Okay, so this is what we need to define next. So for server config, I told you instance type t3.micro, of course. We don't want to get built heavily. And then we have volume size, which was what? Let's take a small example of 8. Okay, because if the volume is higher than 8, you will be built heavily in AWS. And the example tuple we took list. Okay. Uh, yeah, example tuple. So tuple example. Sorry. Now we have what? We have added which values over here. One was string, one was number, one was bool. Okay. So I will say tuple tuple example. Boolean is, oh sorry, second was number. I will say 10, and let's add true to my value. This is done. Next is environment, right? So environment is dev, of course, and then everything is done. Variable validation is so this is not what you define in terraform.tf first, because this is itself a condition check. It does not include any values because this value will be taken from the environment itself, which is over here. So if it is prod, then it will fail with the error condition. Otherwise, if it is dev or staging, then it will pass. So Terraform automatically it will load this .tf file. So Terraform reads the file structure and it sees that yeah. So you have this Terraform.tf, which means the person wants to use this file, and it automatically loads it. You don't need to pass or pass this file to any CLI or take any output from here. Next is the important file, which we have main configuration file. Okay, so over here I said we will use locals, we will use a resource block, and we will also see how we can access these variables inside our main file, main configuration, right? So first thing comes is first thing is locals, right? Because these are short-term or temporary values which we will be using inside our configuration. Okay, so we want to add the name to our instance, and you know it so far that it is a string value. So from variable file, what we will do from this file, what we will do is we will take the environment variable. Okay, uh, where it is, somewhere around here, I guess. Environment is also, yeah, this one. So this is what we took, right? So what we will do is this is the environment dev. Okay, so I want to name my instance by the name of the environment so that I can segregate my instance clearly. Okay, so I will use var dot environment, right? And I will say this is a web server, right? So just for now, not to make the um, example complex, I will take only one instance, because for using it, like what it will do is if I'll take two over here, so then in that case what it will do, it will create two instances by the same name, var.environment web server, right? And you'll get a little bit confused. So in later we will understand that how we can use the count to define multiple multiple instances with different names. But for now, just take a simple example. Now let's do one thing. Let's see what we can do from here else. So we had the common tags, right? So for sure, when I have named my environment, my EC2 instance by the environment name. So what it will do, it will say if it instance will be created, it will say dev hyphen web server, right? So similarly, we have also common tags which we have defined over here, right? So we want to tag our instance so that we can clearly, identify our instance, either it is of dev or staging. So let's do, what we can do is instance tags. We can say instance tags is merge. We are using a merge over here. In the later video we'll understand what is merge, because why I'm using is I want to add the tags and merge it. So let's say the name is local dot instance name, right? This one. So you see how I have used the locals block, right, and reused my instance name over here. Okay, there's some error. Let me check what it is. Mm, 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 mm. Okay, let's see. So merge takes an arbitrary number of maps or objects and returns a single map or object that contains a merged set of elements. Let me check what I did wrong over here. Common tags. So what it does is it merges the set of elements. Okay, so for merge we haven't used the first what you can say, first variable or first value. So we told you, right, that we are going to use common tags, right? So this is the first value and it will be merged with this one, where I am myself doing two things over here. So let's understand this. It's just okay. So I am merging this tag, right, the common tags, which is the project and the owner. Second thing is I am adding the tags which is give the example of local, how we can reuse it, right? So what it will do, it will take the instance name and add over here as a tag and the name. So what it will do, basically it will name your instance by local dot instance name, which is what, dev hyphen web server. Okay, so next thing is, let's just quickly add the environment as well. So let's say environment is the variable name and we are taking it from var dot environment, right? So if it is dev, it will add dev as the environment name. Now next thing is we want to use, okay, let me just not confuse this with this one. Okay, so locals is closing over here, locals is getting closed over here, right? And okay, cool. Right. Now next thing is we will say the tuple example which we took, right, over here. After this we had tuple. So let's take a tuple. What name we can add? Tuple instance or something like that, right? It doesn't matter the name. Okay, so var dot, what was it? It was tuple example, and I've told you guys, we will, for tuple, we access the elements using square bracket index notation, right? And now we have we have list as well, by the name of tuple. I remember list was also there. Yeah, this one. Okay, so the rule which I've told you, first let's do one thing. Let's name the variable first, and then if you remember, I told you that for uh, list. Sorry, this is what set, right? Yeah, allowed ports, and we are using ports. So for set to be uh, parser, like to the Terraform parser, so that it can understand, you first need to convert your set to a list, isn't it? So to convert that, what was the function? To list, and we will use allowed ports. Correct. Now we have resource block, which we will define the AWS instance. It's same. Uh, let's name it web. Okay, and the count which we used, which is var dot instance count, right? AMI ID is the thing which I will fetch it from here. Okay, I don't know which one it is taking, so it doesn't matter. I will just take the AMI ID from here. In our previous video we took AMI ID, right, from this example. Let's just yeah, it's loaded. Now quickly add this one. Okay, we have AMI. Now we need to tell what type of instance, either it is t3.micro or t2.micro. So for that, what we did, we used server config, right? Server config, isn't it? And then the instance type. Okay, for monitoring, we used enable monitoring, right? For availability zone, you remember it very well. We used a list, so we will use the availability zone. Okay, I guess it's zones, and we will take the first one. Again, square bracket index notation because it is a list. For block devices, what we'll do, we will add the volume size. Let's say it is var dot server config. If you remember, inside server config we had two values: instance type and the storage type, storage volume size, sorry. So we have volume size. Now let's do one thing. For tags, let's just reuse our local block. And what was the tags which we added? Instance tags, right? Let me see this one. Yeah, instance tags. So I want to add the tags as well for my EC2 instance. Instance tag. Cool. Now we have everything over here. Okay. The last thing is we want outputs.tf. Outputs.tf. Let's just quickly add this. Let's output the instance ID. Let's say. And how we can do this? Instance ID, if you remember, we used what? For instance ID, let's see. I think we used a list, right? So let's take that one example. AWS instance dot web dot our ID. Okay. Now let's quickly move ahead with the public IP as well, because you want to connect with your EC2 instance. Then in that case you will need your public ID, and the value would be same AWS instance dot web, and we will take this one. Sorry. Okay. Dot public IP. See, so these are predefined variables which you get after you create the resources. We have next thing is allowed port Okay, so let's say if you want to check which ports are allowed for your EC2 instance, then quickly just do one thing. Take this one. And why I'm using local? Because in our main.tf we are using local to add the ports, right? Somewhere around here. Okay. So the port list is inside our locals. So which is why we are accessing this particular allowed ports through the local values. Local dot allowed ports, and again uh, something is missing, I guess. Okay, same name I have added here, so it should be allowed ports list. Now what is the issue? No declaration found for local dot allowed. What I've added? Okay, port list. So I was accessing the wrong way. And let's see, we want instance ARN as well. Let's say instance ARN, and we will add the L value as AWS instance dot web, right? And ARN is such a name over here. Instance ARN. Okay, instance ARN is the name, I think. Right, we are done with that. Now quickly initialize our backend. Let's see if there are some errors. So it is initializing the backend, getting the provider plugins. Okay, let's just wait till then. So we have all the files in .tf. Let's see if we didn't make any mistakes. So the Terraform folder is created. Now quickly let's just do Terraform plan and see which all resources are going to be created. Let's see if we can parse all my configuration. Okay, there is something var.server.volume size inside over here, line number 28. Okay, it is server config, not server. Terraform plan. I hope we don't get any. Okay, instance ARN. This object has no argument. Okay, I think it's ARN only. Let's do this. I think it uses only the ARN. If you want instance ARN, then there are certain parameters. Yeah, that's correct. Certain parameters you want to add. See, we have multiple things. Create. We have AMI ID. We have our resources created. All the configuration passed. Right. US East 1A. Right. So in terraform.tf words file, what we did, we added availability zone as US East 1A. Right. Sorry, this is not the one. Somewhere around, I guess, in this file, we added, yeah, this one, zone, availability zone 0, and zeroth value is US East 1A, which is what it is showing over here. So let's just quickly do Terraform apply and do not wait further, because I think we have done the configuration correctly, and I'm just saying Terraform apply. Okay, I will say yes, I want to create these resources, and it is creating. Let's wait for some time. Meanwhile, uh, I will add these files, configuration files, to the GitHub repository. You guys can take a look and try in your own way. You can create your own example. You can create your own instances. You can add multiple things. Okay, cool. So few things are there. Let me just quickly maximize the terminal, right? So these are the what? These are the outputs which you have got from the outputs.tf file, right? And if you want to reuse it, you can reuse it. and there are multiple ways to reuse it, right? Let's not deep dive into that. So we said we wanted the ARN, so we got that. We wanted the instance ID. Let me just open that file only. Okay, so we said instance ARN, we got that, right? We wanted allowed port list, it is over here. We wanted public IP, the public IP is here, 3.219.45.81. We will match this with our instance when we log into the console and check the EC2 instance, right? So let's just quickly check the instance as well if it is running or not. So 3.219.45.81, right? Quickly go back to this one. Okay, cool. See, we have this. I told you this dev-web server is coming from where? It is coming from the instance name, right? Which we have defined somewhere around here, right? This is the instance name which is then accessed by the local, and through this tag, this is getting the instance name, right? Now we check the public IP 3.219.45.81 and it's the same, right? If we will match the ARN, it will be same, and the instance ID, the last words are 3BE3C. So 3BE3C. So we got this. We got everything for security. Okay. It's we allowed some of the firewall rules. Okay, storage. We said 8 GB. So there is 8 GB, right? So this is the volume which we mounted or we created, right? So in this way you can create and understand the multiple data types, the resources, the variables, variable validation, etc., etc. Okay, so in the next video, what we will understand is we will take this one. Let me go over here. We'll hop into the next topic, which is Terraform expressions and functions. This is also very useful because it has some conditional expressions which are basically used in multiple environments or in any of the use cases you can use. And we have essential built-in functions as well. Similarly to what we see in Python, we have built-in functions. In the same way in HCL, there are some built-in functions. For one, we use this one, right? In one of our example, we used merge. And where did we use that? We use that in main.tf, where you can see somewhere around here. Yeah, we merged two tags, which is var.common tags and the other tag which we defined inside the main.tf. Okay, so one example is done. We will see the other examples. We will see the for loop, for expressions, and we'll meet in the next video. Till then, practice yourself and thank you so much. We'll meet next time.